All right, we're going to start chapter 1, section 6b. We're specifically going to do radical equations. Now, we're going to split it into two parts. This first part is going to be anything with a square root, so square root equations. All right, to solve radical equations, you want to isolate the square root, square both sides of the equation, solve whatever you have left over, and then you want to check all of your answers. Now, if you remember, we had some issues in our rational equations section with those extraneous solutions. Now, a solution we said was extraneous when you plug it back in and you get an undefined answer. Here we have something similar. We're going to check our answers because when you go to plug it back in, sometimes you'll do everything correct, you'll do the math correct, you'll get some answers, and when you plug it back in, you get a false statement. So you want to check that for every single one of these problems. Okay, let's start with the first one. Our first step we had said was to get the square root by itself. And now to get the square root by itself here, right, our square root here is the square root of 15 minus 2x. Why don't we move that to the other side? Right, just to get rid of that negative out front. Right, I know a lot of you don't like to see negatives in front of what you're working with, so to get rid of it, let's just add it to the other side. Right, so let's add square root of 15 minus 2x on both sides, and then over here it's going to cancel out, and you're left with x equals the square root of 15 minus 2x. Once your square root is by itself, you want to square both sides. Now, if you remember, I had said a lot, what's the opposite of squaring something? Right here, I'm going to say what's the opposite of square rooting something. Now, the opposite of square rooting something is going to be to square it. So to square it, we're going to cancel the square root and the square. Right, on the left, we should get x squared equals, and on the right, we should get 15 minus 2x. Right, the radical goes away. Now, this looks like something that we're able to solve. We've done this about 100 times already. Right, so we have an x squared and x a constant. Let's get everything to one side and set it equal to 0. All right, so we should get x squared plus 2x minus 15 equals 0, and now it's just a quadratic in standard form that you're able to factor. You can use quadratic formula, completing the square. The easiest way to do it, I always tell you guys, check if you can factor it first. Right, this one can be factored. Are there factors of negative 15 that add to positive 2? There are, right? So we get x plus 5 and x minus 3 equals 0. All right, let me bring this up here. All right, and now we want to set them both equal to 0. So x plus 5 equals 0, x minus 3 equals 0, and so we should get x equals negative 5 and x equals 3. Now the last step, as you saw on the previous slide, was to check all of our answers. Right, so like I said, once you get this far, you don't want to stop. You need to keep checking, or you need to check your answers and make sure that they satisfy the original equation. Right, so let's start with x equals negative 5. All right, so let's check. All right. Let me just write it down. This is our check. All right, so let's check x equals negative 5. So plugging in a negative 5 everywhere that you see an x is going to be negative 5 minus the square root of 15 minus 2 times negative 5 equals 0. All right, now underneath the radical, we get 15 plus 10. Right, negative 2 times negative 5 is positive 10, so we get 15 plus 10, and 15 plus 10 is 25. So we get negative 5 minus the square root of 25 is 0, and then you get negative 5 minus 5 equals 0. Now, is this true? It's not, right? Because when you combine the negative 5 and the negative 5, you get negative 10 equals 0. This is not a true statement, right? So one of our answers is not going to be x equals negative 5. All right. Now you want to check the other one as well. All right, so here's the other one. Let's check x equals 3. All right, plugging in a 3 everywhere that you see an x should give you 3 minus the square root of 15 minus 2 times 3 equals 0. And we should get 3 minus the square root of 15 minus 6 equals 0. And we get 3 minus the square root of 9 equals 0. And then we get 3 minus 3 equals 0. All right, and now this is a true statement, right? 3 minus 3 is 0. And we get 0 equals 0. This is true. So we get one answer here. X equals 3. So again, it is super important that you're checking your answers each and every single time. Right? You get 2 answers, but only one of them works. Right? So check every single time. Another note, not always is it just going to be one of the 2 answers. Right? As you go through these examples, a lot of them you just get one of the 2 as an answer, right? And that's not going to be the case every single time. I know some of you asked, but it's not going to be the case every single time. Sometimes you get both of them work, so you have to check both. And sometimes you get neither of them work. So again, you have to check both. Right? So let's look at the next one. Now, this is a typo, right? The square root shouldn't be over that equals 0. Right? So it should just be x minus the square root of 3x plus 18 equals 0. And now we're going to work this out the same way as we did the other one. Right? The first thing we want to do is always get the square root by itself. Right? So let's add the square root of 3x plus 18 to both sides. All right? And now it cancels out on the left. So we get x equals the square root of 3x plus 18. All right. And now the opposite of square rooting something is squaring it, right? So let's square the left and the right. So we should get x squared equals, cancel out the square root and the square, x squared equals 3x plus 18. And now just like the last time, we want to get everything to one side. So let's subtract 3x. And let's subtract 18. And so we're left with an x squared minus 3x minus 18 equals 0. All right, and now you want to solve this equation for x. Now, again, do it any way that you like, but always check if you can factor it first because that's going to save you the most time. This one can be factored. We can get an x minus 6 times an x plus 3. All right, what multiplies to negative 18 and adds to negative 3 is going to be negative 6 and 3. All right, so we get x equals 6 as one of our answers, and x equals negative 3. Right, we're just setting both factors equal to 0. And now we're not done. Right, we need to check. All right, so this is going to be our check. Let's check x equals 6. All right, let's see if that works. Plugging that into our original equation is going to be 6 minus the square root of 3 times 6 plus 18 equals 0. And then we get 6 minus the square root of 18 plus 18 equals 0. And 18 plus 18 is 36. So we get 6 minus the square root of 36 equals 0. And then we get 6 minus 6 equals 0. All right, and this is true. 6 minus 6 is 0. So we get 0 equals 0. This works. We get x equals 6 is an answer. All right, now we have to check the other one. Again, always check both. So we get x equals negative 3. So we get negative 3 minus the square root of 3 times negative 3 plus 18 equals 0. All right, so we get negative 3 minus the square root of negative 9 plus 18 equals 0, and that gives you negative 3 minus the square root of 9 equals 0. And the square root of 9 gets you 3. All right, and then negative 3 minus 3 does not equal 0, so we get negative 6 equals 0. That is false. Right, so x equals negative 3 is not a solution. So we get one solution here. All right, let's keep going with the next one. So looking at this one already has the radical by itself. Now remember, that's always the first thing that you want to do. You want to check if the radical is by itself. Now over here it is. So if the radical is by itself, the first thing you want to do now is to square both sides. All right, so square the left and square the right. Squaring the left, the square root is going to cancel with the squares, so we get 4x plus 13 equals, and now squaring 2x minus 1, again, I keep telling you guys, do not distribute the square to each of these terms. A lot of you still make that mistake, and that is incorrect. You need to write it out twice and FOIL it. All right, so we should get 2x minus 1 times 2x minus 1. All right, and now to FOIL this, right, 2x times 2x is going to get you 4x squared. 2x times negative 1 is going to get you a negative 2x. Negative 1 times 2x is going to get you another negative 2x. And negative 1 times negative 1 is positive 1. All right, and this equals 4x plus 13. All right, and now these middle two terms combine to be negative 4x. Right, bring down the 4x squared, bring down the plus 1, and all of this is equal to 4x plus 13. And now let's get this entire thing equal to 0, right? Now this looks like a quadratic. This is something that we were able to solve, right? So now I would subtract the 4x and the 13, right? I know a lot of you like to get the, what's it called? A lot of you like to get everything to the left and set the right equal to 0. That's fine. There's nothing wrong with that. I personally don't like having a negative in front of the x squared. Right, so I brought everything from the left to the right. It doesn't matter, right? It's either way, it's fine as long as it's equal to 0. So we should get 4x squared minus 8x minus 12 equals 0. And now always the first thing that you want to do in these kinds of problems, always check if you can factor it. Now this is something that you're able to factor. You can take out a 4, right? Let's do that first. All right, so we get 4 times x squared minus 2x minus 3. Right, so just take out a GCF of 4. And now if you don't like that 4 hanging out front, you can just divide everything by 4. Right, if you divide both sides by 4, 4 divided by 4 goes away, and then 0 divided by 4 just becomes 0. Right, so we get 0 equals x squared minus 2x minus 3. All right, and now we want to factor this. All right, so now you're just looking for what multiplies to negative 3 and adds to negative 2. It's going to be negative 3, right, and negative 1, or positive 1, sorry. Right, super easy, right? This is probably the easiest way to solve. If you're able to factor it, factor it. I saw on the test and on the quiz, a lot of you tried to do quadratic formula. Some of you even tried completing the square, which if that's what you're comfortable with, it's nothing wrong with that. It's just, it might take a little bit more time to get to your answer. Right, but notice that if we factor it, we immediately get x minus 3 equals 0 and x plus 1 equals 0. Right, so be a little bit more clever with how you solve these problems, right? We get an answer of x equals 3 and another answer of x equals negative 1. But I know I boxed my answers, but I kind of boxed them a little bit prematurely because we always want to check, right? In any kind of radical equation, you want to check that your answers are true, right? So I'm going to write that off to this side right here. Let's check. Let's first start with x equals 3. All right, let's check x equals 3. Let's plug in a 3 everywhere that you see an x. So we get 4 times 3 plus 13 square root equals 2 times 3 minus 1. All right, and then 4 times 3 is going to get you 12 plus 13. All right, the square root is equal to 2 times 3 is 6 minus 1. And then 12 plus 13 is 25. Square root equals 6 minus 1 is 5. And then square root of 25 is 5. And then 5 equals 5. That is true. Right, so we do get that x equals 3 is a solution. Right, that works. Now let's check x equals negative 1. All right, let's check that this is a solution. Right, so plugging it into our equation, we get 4 times negative 1, I believe. What was the original? Yeah, 4x plus 13. Okay, so 4 times negative 1 plus 13, right, square root of that equals 2 times negative 1 minus 1. And so we get 4 times negative 1 is negative 4 plus 13, right? Square root equals negative 2 minus 1. And then we get the square root of 9 equals negative 3. All right, now from here you can see there's nothing that you can take the square root of to get a negative number. Right, so this should be not a solution, right? But you can go even further. You can say 3 equals negative 3, and you can see that that's clearly not true. Right, so x equals negative 1 is not a solution. We only get one solution here, and it's x equals 3. Right? I'm going to keep saying it, and it's super important. You need to always check your answers. Right? Because here we only got one solution. All right? All right, now let's look at the next one on this page. All right, so just like the last one, we want to, and just like all the ones that we've been doing, we want to get the square root by itself, get our radical by itself. And to do that, on the left side of the equal sign, we have square root of 6x plus 7, but we also have a minus 1, right? So let's get rid of that minus 1 by adding 1 on both sides, right? So get rid of it there, and we're left with 6x plus 7. All right, square root of 6x plus 7 equals x plus 1 is 2. And now that we have our radical by itself, let's go ahead and square both sides. All right, and then square root and the square cancel out, and so we get 6x plus 7 equals, again, do not distribute, right? That is not correct. You need to write it out twice and FOIL it. We get x plus 2 times x plus 2, right? If you FOIL that out, you should get x squared plus, and then you get 2x and another 2x, that's going to get you a 4x. And then 2 times 2 is 4. All right, and this is equal to 6x plus 7. And then just like before, get everything to one side. Try and factor it first, right? That's always the first thing you want to check, is if you can factor it. So let's subtract 6x. Let's subtract 7. And then we get 0 equals x squared minus 2x minus 3. All right, now we got the same equation, at least from this point, we got the same equation as the last one. So we know that it's going to be factorable. So we get x minus 3 times x plus 1, all right, equals 0. And now just set each factor equal to 0. We should get x equals 3 and x equals negative 1. And now, like before, you want to check. All right, so I'll write the check up here. So let's check x equals 3. All right, so we should get 6 times 3 plus 7. Square root of that minus 1 equals 3 plus 1. And then 6 times 3 is 18. All right, 18 plus 7, square root of that minus 1. 3 plus 1 is 4. 18 plus 7 is 25. So we have the square root of 25 minus 1 equals 4. Square root of 25 is 5. 5 minus 1 equals 4. This is a true statement, right? Because we get 4 equals 4. This works. So x equals 3 is a solution. This works. All right. And now let's do the same thing for x equals negative 1. All right. So then we should get 6 times negative 1 plus 7, square root of that, minus 1 equals negative 1 plus 1. All right. And then 6 times negative 1 is negative 6. Plus 7, all under a square root, minus 1. Negative 1 plus 1 is 0. And then negative 6 plus 7 should get you the square root of 1. All right, minus 1 equals 0, and square root of 1 is 1. So 1 minus 1 equals 0. This is another true statement. We get 0 equals 0. This is true. So x equals negative 1 is also a solution, right? So this just emphasizes the last point that I was trying to make. Is that in all of these examples, 1, 2, and 3, we got one solution out of the two works. But sometimes both of them will work, right? You can't really know for sure, right? So you need to check every single time. Sometimes you'll get both of them work, sometimes you get one works, sometimes neither of them work, and it's completely no solution, right? So you need to check every single time. All right, so we're going to try two more, a little bit harder examples, right? So one like number 5, I see all sorts of crazy things happening here. So one thing I want to emphasize, you cannot subtract underneath the radical. So you can't say 2 minus x, 3 minus 1. And you can't write that under one radical, right? I see it happen all the time. That's the biggest mistake that I see from the beginning. So the first thing that you want to do is always get one radical by itself. Now this one's a little bit different because you have two radicals, right? So let's start just by getting one of them by itself, right? So the reason this one's so tedious, right? It's the same process as always. It's just a little bit tedious because you have to do it twice. So I'm going to start just by getting this radical to the other side, right? Since it's negative, to get it to the other side, you want to add that radical on both sides, right? So add the square root of x plus 1. So we get the square root of 2x plus 3 equals 1 plus the square root of x plus 1. Now we have one of the radicals by itself. So let's go ahead and get rid of that radical by squaring it. So let's square this side and let's square the other side. Now by doing that, we cancel one of the radicals and we get 2x plus 3. And again, from this point, maybe you got that far. From this point, a mistake that I see is that you square the 1 and the square root of x plus 1. I can't say it enough, you cannot do that. Right? This is another one where you have to write it out twice and FOIL it. Alright, so it's a little bit of a lengthier one because now you don't just have a simple variable, right? 1 plus a variable. You have 1 plus a radical, right? But we're going to FOIL it the same way as always, right? We're going to treat 1 and the square root of x plus 1 each as separate terms, right? So we can FOIL and we can say 1 plus 1 is 1. 1 times square root of x plus 1 is just going to be the square root of x plus 1. All right, and we do the same thing over here. Square root of x plus 1 times 1 is just the square root of x plus 1. And now when we do the square root of x plus 1 times the square root of x plus 1, right, we've seen this before in our radical section way back. When you square a radical or when you multiply a radical by itself, the radical goes away. So I'm going to go ahead and rewrite this. It's going to be 2x plus 3 equals 1 plus the square root of x plus 1 plus the square root of x plus 1 plus, since the square root goes away, we get x plus 1. All right, if you recognize that from the jump, you didn't have to write it twice like I did. But if you like seeing every single step, right, that's what I'm doing this for. All right. Now that it's out of that radical, you can combine like terms, right? We have a whole number 1 and a whole number 1, right? We can combine those on this side of the equal sign to get 2, all right? We just have an x by itself. There's no other plain x's that we can combine it with, so we get 2 plus x. Now, one thing that I want to point out, you have a square root of x plus 1, and you have another square root of x plus 1. If you have two square root of x plus 1s and you're adding them together, that's the same as saying 2 times the square root of x plus 1. All right, so hopefully we're all okay with that. And then 2x plus 3 doesn't change on the other side. Right, so all I'm doing, treat this x plus 1, square root of x plus 1, as a term. Right, if I just had an x plus an x, if you add two x's together, right, that's going to get you 2x. Right, same thing here. If I have an x plus 1 square root, plus another square root of x plus 1, you get 2 of those square root of x plus 1s, right? Nothing crazy there. It's just a little more tedious algebra, but nothing super crazy is happening, all right? And now that we have just one radical in our entire equation, we just have one radical, let's get that radical by itself. So let's subtract 2 and subtract x. Right, because we don't want that with our equation. We want it on the other side to get the radical by itself. So I get 2x minus x, which is just x, 3 minus 2, which is 1, and this is equal to, right, the 2 and the x cancel out. This is equal to 2 times the square root of x plus 1. All right. Now, from here, you can do it one of two ways. it's really a preference thing. If you want the radical by itself completely, and that's the way that you feel is the best way to solve it, so you can divide both sides by 2, right, to get rid of that radical out front. All right, so we get x plus 1 over 2 equals the square root of x plus 1. And now that square root of x plus 1 is completely by itself, right? The other way you could have done it, and I'm going to write it over here, is you could have just done x plus 1 equals 2 times the square root of x plus 1 and just squared it from here. If you don't like the fraction, then you can just square it from here, right? And since they're being multiplied, right, since you have a 2 times a square root of x plus 1, when you square this side, you can distribute the square to each factor, right? If it's a factor, you can distribute the square. If it is a term, you cannot distribute the square, right? So then we get the square root of x plus 1 squared times 2 squared, right? And then 2 squared is just going to get you 4. And then the square root of x plus 1 squared is just going to be 4 times x plus 1. And then on this side, again, you want to write it out twice in FOIL. All right, so then we should get x plus x times 1 is x. 1 times x is also x, so we get plus 2x, or x squared, sorry. X squared was our first one. X times x, and then plus 1 times 1 is 1. Equals, you can distribute the 4 to everything, and we get 4x plus 4. And then from here we can solve it. Now if you did it this other way, it's going to be the same thing. You would just have to square both sides. And now, just like with the factors, if you can square both factors, then you can square everything that's being divided. Right, so you can square the top, square the bottom. And then you get x plus 1 times x plus 1 over 2 times 2 is 4. And then equals x plus 1. So you get the same equation. Now to get the fraction out of there, right, we know how to clear fractions. We just have to multiply both sides by the denominator, right? And then we end up with the same thing. So the 4 and the 4 are going to cancel, and we get x plus 1 times x plus 1 equals 4 times x plus 1, right? So we end up with the exact same equation, right? If you don't like the fraction more than you don't like the radical not by itself completely, then you could have done it this way, right here. And it would have been completely fine so long as you knew that you can square the 2 and you can square the radical, right? If you want the radical completely by itself before you do anything else, then you can divide both sides by that 2, and then you get this step right here, right? Either way is completely fine, right? So at this point, we have the exact same equation. So I'm just going to pick it up from here, right? From here, we get x squared plus 2x plus 1 equals 4x plus 4, just like the other one, and we want to get this entire equation equal to 0, right? It's just a quadratic, right? So subtract 4x on both sides, subtract 4 on both sides, and we get x squared minus 2x minus 3 equals 0. And from here, we want to check if you can factor. That's always the first thing you want to do. Check if you can factor it, and we can, right? We've actually done this before in the previous 2 problems. So we get x minus 3 times x plus 1 equals 0. And then set each factor equal to 0, we get x equals 3 and x equals negative 1. Now you got this far and you're probably like, okay, we're finally done, right? We are not, right? Hopefully we remember at this point we have to check our solutions, right? So that's what makes a problem like this so difficult, right? And I wouldn't even say mathematically it's super difficult. It's just really long and tedious. And you need to be careful with your work, right? So once you get your 2 answers, you can't just assume you're finished. You need to check and make sure that your solutions work. So let's plug them in. We get x equals 3. Plugging that into your original equation should get you, right? Let's see our original equation. Square root of 2 times 3 plus 3. All right. Is that minus the square root of 3 plus 1 equals 1? All right, so let's see. 2 times 6 is going to get you 6. And then 6 plus 3 is 9. So we get the square root of 9 minus 3 plus 1 is 4, square root of 4 equals 1. And then the square root of 9 is 3, minus the square root of 4 is 2 equals 1, and this is true, right? 3 minus 2 is 1. All right, so this works. So x equals 3 is a solution. This works. And now let's do the same thing for x equals negative 1. All right, so plugging in negative 1 into our original equation, we get square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1, and the square root of, or negative 1 times 2 is going to get you negative 2, and negative 2 plus 3 is going to get you 1. So we get the square root of 1, and then negative 1 plus 1 is going to be 0. So we get square root of 1 minus the square root of 0 equals 1, and the square root of 1 is 1, square root of 0 is 0. So 1 minus 0 equals 1, right? This is also true, right? So both of our solutions work, all right? Again, long, tedious problem, right? Lots of algebra. You can see all the work on the page, right? But again, it's more tedious than it is difficult, right? Conceptually, it's the same thing as we've done on the previous problems. You're getting a radical by itself, squaring it to get rid of the radical, and then once you get rid of the radical, you're left with something that you're able to solve. So let's try the same thing for the next one. All right, so similar to the last one, right? I want you guys at this point, I know we didn't do this in class, but after seeing that example, pause the video, try it yourself, at least step by step. And if you need a pause between each step to make sure that you're doing it right, go ahead and do that, right? The whole point of this is that you're able to do it on your own, right? So try it, and then you can keep playing, all right? Now, the first thing I would do, right, modeling it after the previous problem, I would want to get one of the radicals by itself, right? So I would start by first moving the x minus 3 to the other side, right? So let's add square root of x minus 3 to both sides, right? And then that cancels out this radical. So we get the square root of 2x minus 5 equals 1 plus the square root of x minus 3, right? So hopefully you got that part. And now what you have to do is square both sides, right? Once you get the square root by itself, square both sides to cancel out this radical. And then you're left with 2x minus 5 equals, now on this side you have to FOIL it, right? Write it twice and FOIL it. All right, 1 plus, all right, so, plus. Okay. So again, hopefully we got this far. Now let's actually FOIL this side, right? So 1 times 1 should get you 1. 1 times the square root of x minus 3 just gets you the square root of x minus 3. And then another x minus 3 times 1 is going to get you plus the square root of x minus 3. And then the square root of x minus 3 times the square root of x minus 3 is plus the square root of x minus 3 squared. Now hopefully we remember square root and a square cancel out. So we get 2x minus 5 equals 1 plus. Now you can also recognize at this point we have 2 of these square root of x plus minus 3's. Right, so if you have 2 of them, you can write it as 2 square root of x minus 3. Right, that's the same as writing it out twice and adding it. And then plus x minus 3 out of the radical. And now let's combine like terms. On the left side of the equation, we have a 1 minus 3 is going to get you a negative 2. And then we have a plain x by itself, so negative 2 plus x. And then plus this square root of x minus 3, or 2 times the square root of x minus 3. All right, equals 2x minus 5. All right, and now let's get the other radical by itself. Let's add 2 on both sides, subtract the x on both sides, and this is just to get this piece by itself. And then 2x minus x is x. Negative 5 plus 2 is minus 3, or negative 3. And this is equal to 2 times the square root of x minus 3. All right, and now, again, from here you can either get the square root completely by itself, or you can immediately square both sides, since this 2 up front is a factor. I'm going to square both sides right now, just because I know you guys don't like fractions. All right, so let me square both sides. When you square both sides, right, because 2 and the square root of x minus 3 are factors, you can distribute this square. All right, so hopefully we all understand the difference between distributing the square here and distributing the square up here. Up here it was not allowed. Right? You cannot distribute that square, right? That is not allowed because these are terms. Right? If they are factors, you can distribute that square. And then we get x minus 3 times x minus 3 equals 2 squared is 4. Square root of x minus 3 squared, square root and the square go away. All right, and now let's FOIL one side of it. We get x squared minus 3x plus 9. Distribute the 4, we get 4x minus 12. All right, combining like terms, we should get x squared minus 6x plus 9 equals 4x minus 12. And now let's set the entire equation equal to 0 and solve. Subtract 4x, add 12. All right, so we should get x squared minus 10x plus 21 equals 0. Always, always, always check if you can factor it. Right? Don't jump into the harder stuff, right? The quadratic formula, completing the square, is a little bit too complicated for this. You're able to factor it. Right, so it's going to factor what multiplies to positive 21 and adds to negative 10 is going to be an x minus 3 and an x minus 7. And then we get x equals 3 and x equals 7. All right, now are we done? We are not done. We have to check. Right, so I'm going to write over here a little check. As always, right, let's check x equals 3 and make sure it works. Right, plugging x equals 3 into our original equation should get us 2 times 3 minus 5 square root minus the square root of 3 minus 3 equals 1. All right, let's see if this works. We get 6 minus 5 under a square root. 3 minus 3 is 0. All right, square root of 0 is 0. 6 minus 5 is 1, and the square root of 1 is 1. So we get 1 minus 0 equals 1, so 1 equals 1. X equals 3 works, right? This is a solution. And now let's check x equals 7. Right, so we get the square root of 2 times 7 plus 5, or minus 5, sorry. Minus 5 equals the square root of, what was up here? 5 minus 3. Or 7 minus 3, sorry. Whoa, what am I doing? Hold on, sorry. Let me just rewrite the whole thing. Okay, it's going to be the square root of 2 times 7 minus 5 minus the square root of 7 minus 3 equals 1. Okay, and then 2 times 7 is 14. 14 minus 5 is 9, so we get the square root of 9 minus 7 minus 3 is 4. Square root of 4 equals 1. Is this true? It is, right? Because the square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1. That's true, right? We get 1 equals 1. So another one where we get both our solutions. So again, always check both answers, right? Because sometimes you'll get both our solutions, sometimes one, sometimes neither, right? Again, another tedious problem, but it's not super difficult. It's just really tedious and requires a lot of work, right? But conceptually, again, exactly the same as before. You just need to get a radical by itself, get rid of that radical, and then solve what you have remaining, and check your answers. All right, last two examples. So let's start with number 7. Now, number 7 is similar to the previous two that we did, in the sense that we have 2 radicals instead of 1. But this one is already in the form that we want it, right? We already have a radical on one side of the equation, So all we have to do now as our first step is just to square both sides. Right, squaring both sides, that radical is going to go away on the right. And so we're left with x minus 1. And on the other side, we want to write it twice and FOIL it. All right, and so once you write it twice, we're going to FOIL. Right, again, just like the last one, treat the square root of x minus 5 as a term. Right, it is a single term, so you want to multiply it by itself, and we get the square root of x plus 5 squared. All right, and then minus, right, square root of x plus 5 times negative 2 is going to be minus 2 square root of x plus 5. And then we're going to get the same thing again. Negative 2 times the square root of x plus 5. And then our last one is going to be negative 2 times negative 2 is going to be a positive 4. And this is equal to x minus 1. All right, so over here, the square root and the square are going to cancel out. You can also combine like terms here, right, because you have a square root of x plus 5 and a square root of x plus 5. Negative 2 minus 2 is going to get you a negative 4. Right, so again, treat this as a term, right, the square root of x plus 5. Right, treat it as a term, and so when you combine them, you can just combine the coefficients. So we get negative 4 square root of x plus 5, and then we get x plus 5 plus 4. All right, and this is equal to x minus 1. All right, and now combining like terms even further, we can combine this 5 and the 4, and then we get an x plus 9 minus 4 square root of x plus 5 equals x minus 1. And now we want to get our radical by itself. All right, so let's go ahead and subtract x on both sides and subtract 9 from both sides. All right, so we get negative 4 square root of x plus 5 equals, this x and the x are going to cancel. X minus x goes away. So we get negative 4 square root of x plus 5 equals negative 10, right? Negative 1 and negative 9 are going to combine. All right, and now this makes it a little bit easier because now we only have one answer to check, right? So let's go ahead, let's square both sides, right? This is how I've been doing it before. If you don't like doing it that way, again, just get the radical by itself by dividing by negative 4, right? But you can square each factor, right? And by doing that, we get negative 4 squared, square root of x plus 5 squared equals negative 10 squared is going to be positive 100. All right, so we get 16 times, and then the square root and the square are going to cancel, so we get 16 times x plus 5 equals 100. All right, and now you just want to solve for x. Let's distribute the 16. So we get 16x plus 80 equals 100. All right, and now let's subtract 80 on both sides. And we get 16x equals 100 minus 80 is 20. Divide both sides by 16. And then we get x equals 20 over 16, but we can simplify that into 5/4. Right, so we get x equals 5/4 as one answer. We get only one answer here. And again, as always, check your answers. So let's check right here. All right, now I know what you're thinking. It's a fraction. All right, oh boy. How are we going to check a fraction? Same thing as always, right? Just plug in 5/4 everywhere that you see an x. 5/4 plus 5. Square root of that minus 2 equals the square root of 5/4 minus 1. All right. Now the hardest part here, this isn't even that hard. This is just annoying. Right? I know you guys don't like the fractions. Right? Find a common denominator. Right? So write 5 over 1 times 4 times 4. Right? And then you're going to get 5 over 4 plus 20 over 4 right, minus 2. And then you get, what do we get? 25 over 4? Square root minus 2 equals, and then same thing here, right? Over 1 times 4 times 4 equals the square root of 5 over 4 minus 4 over 4. And then we get square root of 25 over 4. If you're dividing under a radical, you can square root the top, square root the bottom. So we get 5 over 2 minus 2 equals square root of 1/4. Again, you can square root the top, square root the bottom. And then let's get a common denominator here. So times 2 times 2. So we get 5 over 2 minus 4 over 2 equals 1 over 2. And this works, right? 5 minus 4 is 1 over 2. 1/2 equals 1/2. Right? This is true. So we get 5 over 4 is a solution. All right. Now let's do the last one. Or let me zoom out in case you guys like to see the big picture. All right, this is the entire problem. All right, now let's look at number 8. Again, just like the last one, let's square both sides right away. Why can we do this? Because you have one radical already by itself. All right, so let's square the left, square the right. And then squaring the left, the square root and the square are going to cancel. You get 4x plus 1 equals, write it twice and FOIL. Right, so I know these are hard, but at this point, maybe you're kind of getting it a little bit better. It's tedious. Like I said, it's tedious. The more you do it, though, it doesn't become super difficult. It just becomes quite the process. All right, so we get 4x plus 1 equals the square root of x minus 1 squared, right? Because we get this square root times this square root plus 2 square root of x minus 1, and then times the two inners is going to be another 2 square root of x minus 1, and then 2 times 2 is 4. All right, square root and the square are going to cancel. So we get 4x plus 1 equals x minus 1 plus, let's combine these radicals. Right, if they're the same radical, you can add them. It becomes plus 4 square root of x minus 1, and then plus 4. And now let's combine like terms. We can combine negative 1 and positive 4. So we get 4x plus 1 equals x plus 3 plus 4 square root of x minus 1. All right. And now let's get everything to one side, or let's get everything but the radical on one side, right? So let's subtract x, subtract 3. All right, minus x minus 3 should get us 3x minus 2 equals 4 square root of x minus 1. All right, and again, you can divide by 4 if you like the radical completely by itself. But if you want to avoid the fractions, you can square it from here. All right, and then distribute the square because they are factors. Again, if they're factors, you can distribute the square. All right, and then on this side, these are not factors, so you can't distribute the square. Write it twice and FOIL it. All right, equals 4 squared is 16. Square root of x minus 1 squared is going to be just going to be x minus 1, right? Square root and the square are going to cancel. All right, and then on this side, 3x times 3x is going to get you 9x squared. All right, and then minus 6x minus another 6x. All right, plus 4 equals, to distribute the 16, we're going to get a 16x minus 16. Combine like terms, so we get 9x squared minus 12x plus 4 equals 16x minus 16. All right, now let's get everything to one side. All right, again, this is just a quadratic. Oh, hang on, plus 16. Yeah, and then we should get 9x squared minus, what's that going to give us, 28x plus 20. equals 0. All right, now we want to factor it, or let's check if we can factor it. All right, so this one, if there's something in front of the x squared, right, let's multiply the first and the last. Right, you can write the big X, or you can do it another way. Right, so I'm gonna write 180 on top, right? 9 times 20 is gonna get you 180, right? Minus 20, or minus 28 on the bottom, right? So you're looking for factors of 180 that add to negative 28. Should be negative 10 and negative 8, or 18, sorry. Yeah, negative 10 and negative 18. Should get you that positive 180, and when you add them, should get negative 28. Right, so let's factor it. You can factor it however you want. You can slide and divide, or you can do it by grouping. Right, I know a lot of you like grouping, so let's split up the middle term. We get 9x squared minus 18x minus 10x plus 20 equals 0. All right, and now let's group. Take out a GCF from the first pair is going to be a 9x. So we get x minus 2 on the inside. We can take out a negative 10 from the second group and also get x minus 2 on the inside. So we get 9x minus 10 times x minus 2 equals 0. And then let's set each factor equal to 0. So 9x minus 10 equals 0, x minus 2 equals 0. And then we get x equals 2 as one of our answers. All right, 9x equals 10, divide both sides by 9. We get x equals 10 over 9 as our other answer. Again, check all your answers, right? I know it's annoying, but you gotta do it every single time. You need to make sure that you're getting the correct answers. All right, so let's check over here. All right, so let's check 10 over 9. Let's get that one out the way. All right, so let's check 10 over 9 should get you the square root of 4 times 10 over 9 plus 1 equals the square root of 10 over 9 minus 1 plus 2. All right, and so we should get 40 over 9 plus 1 equals the square root of 10 over 9 minus 1. I'll find the common denominator all in one step. Right, and then for this side, right, divide with the 1, multiply by the 9. We want to get the common denominator of 9. Same thing over here. Divide the 1, common denominator of 9. Let's multiply the top and the bottom by 9. So we get 40 over 9 plus 9 over 9 under a square root. And then we get 10 over 9 minus 9 over 9 under a square root plus 2. All right, and then over here we get a 49 over 9 square root equals the square root of 1 over 9 plus 2. And then, as always, if you're dividing under a radical, you can square root the top and square root the bottom. So we should get 7 over 3 equals, same thing here, square root the top, square root the bottom, 1 over 3 plus 2. And then one more denominator, common denominator. Multiply the top and the bottom by 3, we should get 7 over 3 equals 1 over 3 plus 6 over 3. And that does get you a true statement, right? We get 7 over 3 equals 7 over 3. All right, so we get 10 over 9 is a solution, right? This works. All right, let's do the same thing for x equals 2. All right, so I'm going to check over here, x equals 2. All right, so checking x equals 2, we should plug that into our equation. We should get 4 times 2 plus 1 equals the square root of 2 minus 1 plus 2. All right, and then we should get 8 plus 1 equals 2 minus 1 is 1. And then 8 plus 1 is 9. Square root of 9 equals 1 plus 2. And then we get 3 equals 1 plus 2, which is 3. All right, so this is also a true statement. So this is another solution. So both of our solutions work. Again, very tedious. You can see the amount of work that's required for this problem. Right, but the same process as always. All right, get the radical by itself, square both sides, and then repeat that process until there are no more radicals.